So this lecture is titled "Working with Files," but it's a little bit more of like, yeah, we're working with files. I also throw in some stuff on the dot format on format strings and stuff, which I probably should have included earlier, and I apologize for not including it earlier. But to be fair, your TA covered format strings as well, and I think maybe some people just didn't go to section or didn't watch the stuff. So
Very like rudimentary coverage.
a little bit of just rudimentary coverage. Okay, well, this is also going to be rudimentary coverage. I mean, how much can you cover in, one lecture anyway? So, but here we'll take a look, right? Okay. So this concept of persistence is the idea that, after you create something, you calculate some values, maybe you want to use it later, right? And pretty much all of the code that we've been writing and all of everything we've been doing is transient. As soon as you quit Python, as soon as you close your Jupyter Notebook, those values are gone. And if you're coming from R, my recommendation is generally all of your kind of code editors, you should always, well, I don't know about always, but with R and with data things, I would say don't store things automatically. Like in R, you have the ability to kind of store your workspace. I would say don't do that, and just get in the habit of generating these things. And if you do need to reuse stuff, you explicitly save it. So yeah, similar ideas in Python. As soon as you kind of run, you run your code during your session, you produce output, and then when you close it, it's gone, okay? And sometimes you need things to be persistent, and that means you need to store or at least write some of your data somewhere, okay? So one thing you can do is you can run open. Oh, okay, so before I go on, is Git working for everybody as far as like uploading the stuff and downloading the content? Okay, so here's today's lecture is an example where I think Git is quite nice, because I think I uploaded like 5 files, and rather than having to download all 5 and save them somewhere in your machine, you can just do git pull, and it will git pull upstream main, it will get all 5 of those files automatically. So you can do that. Okay, but anyway, you can open a file just using this command open. And if you want to, you have different modes. You can like read and write to it. And if you want to write to a file, which is what we want to do, we want to be able to save things to it, you use W as the parameter. So you do open, filename.txt, comma W. And if the file exists, running this command will completely replace the file, right? And if the file does not exist, then it will actually create it. So here I'm going to run open, and I'm going to just assign the result of open to the object name fout for file out. Okay, and this we're going to interact with file out using the .write method. Yes, question.
What does the W parameter do?
The W makes it writable. So as far as opening the file, you can do like read mode, and that will allow you to kind of intake values, okay? And it will leave the file as is. Write mode says, okay, we're going to start over with kind of a blank thing. So let me see. I don't know if I'm allowed to have this open at the same time. So a lot of times your computer will lock things off when it's being handled, but let's see. If I do output.txt, currently it's blank. I'm going to go ahead and exit out of here. I'm going to write this, so I create a string called this is the first line of the text, ending with a /n for a new line character, and I'm going to run the method fileout, fout.write, line 1. Okay, so I'm going to go ahead and run that. And it comes back and it says I wrote 32 characters. And so let me open up output.txt on my
You can also open it for JupyterLab.
yeah, let me just see. Did this oh, you know what? I have to close the file for these things to take place. Okay, so I got file out.write, and then I'm gonna write another line. This will be the second line of text. File out.write again, and then now that I'm done, I close the file. Okay, and then now that I've closed the file, it should be it has the stuff that I've written to it. Okay, sorry, yeah. And then again, if you want to interact with it again, you have to open it. Okay. And yeah, let me pull up the contextual help here. Okay, so as far as open goes, there's different modes, right? So this is the help shown for open. You give it the name of the file, and then these are different options. Let's see. The mode is, it defaults to R. Okay, so R is for reading, W is for writing, truncating the file first. X creates a new file and opens it for writing. A, open for writing, appending to the end of the file if it already exists. Binary mode, text mode, disk file. I'm not sure what that is. Okay, but anyway, this is the help. This is the help for open. Okay, so yeah, you can open it and do f out, write, and do f close. There is you can use the keyword with, and this will automatically open and close the file after you're done. Okay, so you can say with, and then open output.txt w, and again, the w mode wipes out the file, right? W mode wipes it out. If I changed it to say A will append it. Okay, so here I can, if I do A, this will run, and that's not what I wanted. So here's output.txt, and so A appends it, right? Versus if I rerun this using W, this will truncate it and basically wipe it out and reset it, right? So those are the different modes. Do you want to continue adding to the existing file? You use A. You want to start off with a fresh file and write directly to a clean thing. You use W. Different options here. Okay, so that's with, and that will open it, and then when it's done, it'll automatically close it. Okay, and then if you want to read from the file, so remember I just kind of wrote just 2 lines to it after wiping it out. You can read from the file, and then now with open as file, you can kind of iterate, and iterating over each, you will iterate over each line, right? So it'll say this is the first line of text, this is the second line of text, and it kind of iterates through that. And within each thing, you can kind of iterate, whatever you want, right? So I can do print I dot upper, right? And you can kind of do whatever it is you want with the file as you read it in. Okay, when you use write, the argument has to be a string. The easiest way to kind of convert things to strings is to use str. So here I have x as 42.3, and if I wanted to do x plus the string is my favorite number, if I wanted to kind of create a new string, if I try to do this, I'm going to get an error. It's going to say you have a float over here and you have a string over here, and I can't add those things together, right? So what we do is we convert this float 42.3 into a string. Basically, it just takes whatever it is and it wraps quotes around it. And that's how you would do it. And now you get 42.3 is my favorite number, and that's fine. And you can take that string, write it to a file. Okay. the other kind of way to go about format where if you want to kind of place values into a string is you can use the format specification, I guess, mini language, where you use these curly braces as kind of placeholders, okay, or we call these replacement fields, right? And so here I have 12.34, and I create a pair of curly braces, and I do curly braces is my favorite number, and I'm going to do dot format, and I put the X in there, and it puts that inside there, okay? If you want, you can kind of pass it multiple arguments here, okay? And so here I've got 12.34 for X, 37.8 for X2, and I have two replacement fields. I got blank is my favorite number and blank is my second favorite number, and this is going to pair things up positionally. So I've got format with using the X value and the X2 value, and it puts the 12.34 in there and 37.8. Okay, you can give it indexes. All right, so you can inside the curly braces, you can give it indexes, so you can kind of refer to the same number again. So here I'm going to do index 1. So if I do format X comma X2, okay, 12.34 will be index 0, and X2 37.8 will be index 1. So it's going to say 37.8 is my favorite number, and 12.34 is my second favorite number, and again my favorite number is index 1, 37.8, right? And so that's what we have. And this one I've got the triple quotes to kind of allow it to have my whatever I'm saying spread across multiple lines. There are different kind of letters and stuff that you can do. So inside your curly brace, when you create your reference field, you can specify after the index of which value to use, you can specify colon and G to indicate kind of, I guess, the formatting way. So G will do general format, and the default is to round to 6 significant figures. And you can specify more by using something like .8G, okay? And this will be like 8 significant figures after the decimal here, okay? Or places after the decimal. So here, I for X, I've got 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here I got 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are weird favorite numbers, but let's go ahead and see what this ends up looking like. Okay, so the default is 6. So even though I've got these leading zeros, 0, 0, 0, and then 1, 2, 3, 4, 5, and then the 6th figure gets rounded off to 7. Okay, so 0, 0, 0, 1, 2, 3, 4, 5, 7 is my favorite number. And then over here I've got a whole bunch of zeros, and at this point it says, I'm going to start reporting in scientific notation, 1.23456.7, and then, the real value is 789, but it rounds off that last value to 9. Okay, so this is just kind of the default behavior. Is like it's going to just round off things, and that's probably fine in a lot of cases. But sometimes you're like, I really want it to appear a certain way, and so here is another way. So G allows for kind of both, .000 representation, but also scientific notation. F is for fixed point format, okay? And the default is 6 places after the decimal. You can also do, say, 8 places after the decimal, okay? And so 6 places after the decimal will be 0, 0, 0, 1, 2, 3. And then it rounds off everything else. The 4, 5, 6 just kind of disappears. Over here with .8F, fixed 8 places after the decimal, 0, 0, 0, 0, 1, 2, 3, and then because it goes 4, 5, 6, that 4 gets rounded up to a 5. Okay. Other things you can do. If you don't like this replacement field business, you can always kind of convert to and use the plus operator, and that works. You don't have to specify the placeholder indices, so I can just do colon this and that. And so here I've got 3 placeholders, and if you have a string, you can do colon S to leave it as a string. So I've got Joe Bruin. I am 100 years old. Well, how old is Joe Bruin? 1919? Is he 103 now? All right, we will update that. And 83, what's my favorite number? What is, I don't know. Okay. 1919. We had our centennial, 2019. I don't know. Okay. There you go. All right. I'm trying to think history of UCLA. I don't know. When did we come to Westwood? That was like some other day also. Okay. All right, and these are taken also straight from the Python documentation on this string format, HTML string, right over here, business. Okay, so here, 1, 2, 3 with ABC, that fills it in. Same thing, without the indices specified, we get ABC. 2, 1, 0 will give us CBA, and this is, remember tuple or just sequence unpacking. So here I just have the characters ABC as one thing, but if I put a star into it, it will explode that and put each value in there. Okay. And here I've got Abra and CAD, and this is kind of a funny thing, right? So if I do this, if I do 0, 1, 0, it becomes abracadabra. All right. It might be more handy to have named names for the values that you're going to place. So if I have coordinates, latitude and longitude, instead of passing it index 0 and index 1, you can specify, basically almost like a dictionary, where you name each of the fields. Okay, so that's fine. Okay, or yeah, you can create a dictionary, right? Create a dictionary, and then when you pass it to the format, you can do **, and this will explode the dictionary into keywords and arguments. So here the keyword being latitude and the keyword being longitude, the keys and the values, and so that will also work there. Okay. And then if you want to insert a whole bunch of like spaces, you can use the less than or greater than or caret sign, and this will basically take, if you have whatever text string that you have, okay, so here I'm going to write left aligned, and it's going to produce a string with a total of 30 characters, okay, and this is left aligned. So the output is left aligned, and it just pads it with a whole bunch of extra spaces so that the total length is 30 characters. Right aligned, it pads it on the other side so that the text is right aligned, and then here it's going to pad the left and right side so it's centered. Okay, so these are kind of little handy little things, and I probably should have done it earlier in the quarter, but I don't know where it would have fit in. Somewhere between, I don't know, maybe between tuples and I don't know, whenever. Yeah. Did you have a question or? No. Okay. Have I given you any view quiz answers today? Okay, let me give you your first one. Today's first answer is D. D as in dog. D as in dog is your first view quiz answer. Okay, let's do, okay, working with stuff in your own system. So I have import OS, and this allows you to work with your system. I think it works for both Mac and Windows, although it's been a while since I've tested it on Mac, so you'll have to verify if you got a Mac that this indeed still works. So I do import OS, and I can do os.getcwd for your current working directory. And so for me, I am in the folder users, miles, and OneDrive teaching 21 for stats 21, and then this folder 2022, and whatever. And wherever you open it, does it also show your path? Something? Okay, so it works. Great. Okay. A lot of times when you provide a file name to Python, it's going to provide a relative path. Okay, so generally when I provide the file name output.txt, that's going to be the relative path to my current working directory. Here I can ask what is the absolute path? Okay, the absolute path will always kind of start with on a Unix machine like Mac, it'll start with kind of that initial slash, I think / and then I think the default will be /users/ your name / will be your home directory, and then probably desktop or something, downloads or something. Okay, whatever it is. You can check to see if a file exists with .exists. Okay, so memo.txt, that doesn't exist in my folder, so I get a false. .exists is true, and so you can imagine this being useful when working with a file. You want to do if it exists, then we'll open it to read mode or append mode, and if it doesn't exist, then we'll go ahead and create it from scratch. Yeah.
It only works with the working directory, right? Or it only checks the file what directory you're in.
Yeah. So in general, when you specify a thing here, it'll be for your working directory. But you can, like if I wanted to, I can do I can give it the absolute path as well. So here's the absolute path. On Windows, Windows structure uses these backslashes, and backslashes have to be escaped. So that's why you see the double backslash on a Windows machine. So if I wanted to, I can also do os.path.exists, and I can provide it the absolute path as well, and that will work, right? And if I do output, if I put something else in there, that doesn't exist. Okay, yeah.
So sorry to bring it back to this, but so for the formatting, where it was like the less than and then the number to like set the size.
Yeah.
Is there a way to like make it so that that's like the hard limit of the whatever variable you put in there? Because for example, like on the homework, when I use that, like if they're an integer longer than whatever I specify, they still go on till they're end.
Oh, they go longer?
Yeah.
Yeah, integers.
Not integers, sorry.
Floats? Well, you can float. You can specify the float to round to a certain number, and then you can pad it, I think. Yeah, I got to play around with it before I can give you a final answer. But yeah, usually you can handle most of the desired text operations you want to do. But yeah, we can kind of mess around and see what things it produces. Okay. You can check to see if something is a directory. So, .txt, this is a file and it's not a directory. In my working directory, I have a .git directory because it's hidden, but that is a directory that does exist. Okay. And you can also do list directory, and this will tell you the contents of your current working directory, which I think in this folder I don't have anything that needs, that will give away too much information about my computer or something. This is just kind of the file of everything on my GitHub for repository for this thing, so we can see all of the files kind of listed. So you can do os.list directory, and you can reference values in there. Okay, another just kind of a side note thing is sometimes you will encounter errors, and how do you deal with this? So there is there's something called try, okay, and try basically will attempt to do something, and if it gets an error, then it's not going to crash. It'll run whatever code you have in the exception. Okay, so if I say open this thing bad_file, which doesn't exist, right? So you can check, what's inside here, and bad file doesn't exist. The default is read mode, which and that's only going to work if the file does exist. This returns an error, right? So I get back an error. No such file or directory, bad file. And when you're working in Jupyter or IPython in interactive mode, this is fine. You can kind of keep going, right? But you could imagine writing some kind of script that you want to send someone, and then you say run this, and then as soon as it encounters an error, the script stops running, and now it doesn't know what to do. Or some kind of function, when it encounters an error, it doesn't know what to do. So you can say, you can tell it try, and it's kind of like an if and else. It works like if and else, except it's you try something, and if this thing results in something, if it results in an error, then it's not gonna then it's gonna quit and go to the exception. Okay, so this thing, when it tried it tried to open the bad file. The bad file doesn't work. So then it quits out and runs the exception block. Okay, and so this isn't going to encounter an error. It just it runs the code in the exception side. Okay, so if everything goes well in the try, then it skips the exception block and it continues on with whatever other code you have. Okay, and but if it does encounter an error somewhere in the try, and you can have multiple lines inside the try block. Okay, you can have multiple lines, and if it does encounter an exception somewhere in there, it's going to exit the rest of that try block. It's going to stop whatever it's trying to do, and it's going to immediately switch to the exception block and run all the lines of code in there. Okay, starting from the first line of code in the exception block. Okay, yeah.
So can you run like nested tries?
Can you run nested tries? You can. Okay. I would probably recommend sequential tries over nested tries. Okay, so try this, and if that works, keep going, and then for the exception, then quit entirely or something. But yeah, there's not a rule against nested tries. But here, let's see, Python nested try. We can have, let's see what this person says. Yeah, and then for the exception, you can have multiple exception blocks for basically different kinds of errors that you encounter. But let me see. I don't know. I'm going to just say you can read a little bit more. So, but you can have nested tries. But yeah, I would generally, if you can avoid too much nesting, it makes your code a little bit easier to read than nesting. So if it's like you need to do this, and then you need to do try this out, and then try this out. See if you can think of it more as a sequence. That you do a try except, and then later on a different try except or something. That might make more sense depending on the situation. In other cases, yeah, the nested try blocks might make the most sense as well. Okay, here is there's something called the DBM. Okay, the DBM database. It sounds fancy, but really, basically, it's just a way for us to store a dictionary somewhere onto the hard drive where we want to be able to kind of open it later. Okay, so you have to import this module, the DBM library, and then you would call dbm.open, right? And this opens a connection to some file, and if it and with option C, this will kind of create it if it doesn't exist. And but unlike the write mode, it's not going to like overwrite it. Okay, so here I'm going to do dbm.open captions C, and basically this is kind of like adding keys to a dictionary. So I'm using code straight from the ThinkPython textbook, and the author of ThinkPython very much enjoys Monty Python. So I don't know if you watch any of those comedy movies, but so anyway, we have John Cleese. Here's kind of this idea of we're just entering a string called Cleese.png. So this is not an actual file or anything. It's just the string that could be a file name, but that may or may not exist. It's just the string, and then that's the key, and then the value associated with it is going to be photo of John Cleese. Okay, and then later on, if we want to kind of retrieve this value, we can call, just like a dictionary. You ask, you say, get this thing, okay, and it comes back and it says B photo of John Cleese. All right. And here we can enter another thing, okay? And if you need to delete stuff, you can do delete whatever it is by key, just like you would interact with a dictionary if you needed to delete a key. And then you can kind of iterate through the entire database, right? So you can kind of go through each key in the database, or basically a dictionary, each key in the dictionary, print out the key along with the value associated with that thing. Okay. Oh, I forgot. I put in. I pickled the list here. Okay, so sorry. This there's extra stuff that we hadn't added to it. This thing appears here. So okay, and then when you're done, we do .close. Okay, and this will kind of create basically a few files in our working directory, captions.bak, captions.dat, and captions.dir. So these files get created when you create the DBM. All right, so sorry, this entry in here we did not talk about yet. Okay, this is called a pickle. All right, and it looks funny. Okay. So one thing is that as far as DBMs go, it can only store strings or bytes, okay? And if you wanted to store something like a list, so here I created a list, 1, 2, 3, okay? And I can say, okay, what is this type here, okay? The type is list, and here if I wanted to store this to the dictionary, right? So here I'm going to open up the dictionary, and if I try to take T and I store it into try to create an entry in the dictionary here or into the DBM, I get an error. Okay, it says values must be bytes or strings, and here I've got a list, and we're trying to do this, and this is not gonna work. Okay, so what we're gonna do is we're gonna pickle the list. So it's kind of it's, again, I don't, CS people they come up with they try to be cute with their analogies and stuff, right? So it's the idea of, if you wanted to store some kind of vegetable long-term in storage or something, so it doesn't rot, one thing you can do is you pickle it and then you put it away in storage, and then you can come back and enjoy it later, right? You pickle your cucumbers for things later, right? like every culture has their weird pickled thing that, you know, if you didn't grow up eating it, you're just like, oh gosh, why does this smell so bad and stuff? But like, but it's just like, that's just what pickling does, right? Pickling just creates this very pungent thing that somehow is enjoyable for people who enjoy the flavor, right? But anyway, what we're going to do is we're going to take different objects like a list or something else, and then we're going to pickle it, which basically will convert it into a form that we can then store away in this DBM. Okay, so here I'm going to import this module pickle, and what we will do, okay, so we call pickle dump s, okay? It looks like dumps, but dump s is basically dump the thing into a string, okay? So what it will do is it takes, you know, currently our list T is this list 1, 2, 1, 2, 3, and we're going to say make it into a string, okay? And this is what it looks like, okay? This thing, it comes back /x80/x04/x95. This is not meant to be read by a human. It is the string representation of the list. And somewhere in here, it contains the information for 1, 2, and 3 that says, yeah, 1 is an integer, 2 is an integer, and 3 is an integer, or whatever, okay? And but now that it's a string, we can take this and I can store it into the DB, okay? And so I can just, I can do this. It doesn't produce an error because this is now a string, and then I can close the DB, all right? And so now that I've saved this, I can now retrieve it, okay? So I can do use open, okay? We're gonna open the captions DB, and now I can retrieve this, okay? And when I retrieve it, I get back the exact string that I saved, right? And I'm like, oh, well, that's not, I didn't want that, okay? So now I need to be able to convert from the string back to the original object, which was a list with the values 1, 2, 3. So we're going to take this thing and we're going to use the function load_s. Load_s will load a string back into the object. So when I do that, now it says, oh, this string representation, when I convert it back to a Python object, it is now this list 1, 2, 3. Okay, so it's a little bit of a weird process that allows us to store things that aren't strings, because, you know, for whatever reason, the DBM structure, like a dictionary, allows you to only kind of store things that aren't that are strings. And if you want to store something different, you have to pickle them. Okay. So here I've got another example here. Let me give you your second view quiz answer, which is the letter B. B as in bear. B as in Bruin, or whatever. Lots of words start with B. Okay, we can name a bunch of them, but but I won't. Okay. So here, let me pull up the contextual help on database. And this is a little bit too much.
Is there like a size limit on the files that can be imported?
I don't know. Maybe. How big can I pickle on Python? Python can pickle byte objects bigger than can pickle handle byte objects larger than 4 gigs. Okay, pretty big. but a comprehensive guide to pickle. Let's see. Oh, geez, I don't want to.
It says comprehensive.
Yeah. Pickle, dump, open, load. Okay, Python pickle dump s. Okay, so dump, write the pickled representation to the object file object pickler, and then dump s as a byte object instead of writing it to a file. Okay. Well. Okay. So you can work directly with a pickle file rather than a. So here we were using the DBM. Okay, so DBM only allows for strings or byte objects, and that's why we're using dump s and load s to kind of do strings and things like that. But you can also create pickle files directly. And so here I've got some stuff. I've got basically a list, another list, and a string here. So I've got 3 different objects, and I want to kind of pickle them together. And so I'm going to create a pickle object, and open WB mode, I think, is write and byte mode. Let me just verify. Okay, writing and binary mode. Okay, so that here I'm going to write a new file, and then B will be for binary mode, which allows us to kind of work with things not as strings but in binary. And so I've got file 1. Or this list containing 2 strings, this list containing 3 integers, and just a string. And so I'm going to open, here is a pickle object, or a pickle file, okay? And we're going to write it in binary mode, okay? And here I'm going to do .dump, okay? So not dump s. Dump s creates these strings that I can write. Dump is just going to put these, write them down as in binary kind of bits, however it gets stored here, okay? So I'm going to kind of put the 3 objects together into a single list, object 0, object 1, object 2, and we're going to dump it into that file. Okay, and that's done. It creates the thing and it loads it, and if I look at objects.pickle, and if I try to open this up directly, okay, it's not quite readable. There's a whole bunch of stuff here. All right, so you can see some of the stuff, right? File 1 something else, and there's like a bunch of kind of gibberish in here. So it exists, but probably, it's not intended for us to look at it directly. But what we can do is we can read it back open. So I can load this back using open the thing in read mode, read binary mode, and we will call pickle.load. Okay, so we load the file, and because I stored it as object 1, object 2, object 0, object 1, object 2, I can unpack that thing, and I can unpack the objects, and I get my 3 different lists here, or the 2 lists along with this string. Okay. And I linked over to this documentation on what can be pickled and unpickled. And let's see. The following types can be pickled, none, true, false. Okay. integers, strings, tuples, functions, classes accessible from the top level of a module, and instances of such classes whose double under dictionary of or the result of calling get state is pickable. Okay, I'm not quite sure what that last bullet point means. Attempts to pickle unpickable objects will raise a pickling error. This is great. Okay. An unspecified number of bytes may have already been written to the underlying file. Trying to pickle a highly recursive data structure may exceed the maximum recursion depth. A recursion error will be raised in this case. Okay. And note that functions are pickled by fully qualified name, not by value. This means that only the function name is pickled. Okay, so we're getting quite technical into this, but let's see. So yeah, you have pickle string, pickle dump s will create the string version of a pickle, or you can kind of get that. Okay, well, we'll keep it simple, but in some cases you might need to use some of these more advanced pickling functions, but I don't know enough to go fully into this. Okay. Let me give you your last view quiz answer, which is the letter A. A as an apple. A as an apple is your third view quiz answer, and we'll call it a day for here. Okay. On Friday, we'll start taking a look at pandas, which I'm excited to introduce to you guys as well. Okay. All right. So we'll see you all on Friday.